There are only a handful of experiments in physics
that completely transformed physics.
At many people's top of the list would have to be the Michelson-Morley experiment.
In the 19th century, physicists thought that since sound waves travel through air, light waves must travel through some sort of medium as well. They called this theoretical medium ether.
The famous luminiferous ether. This magical medium that was hypothesized to be what light required to move through the vacuum of space.
The Earth orbits the Sun at about 66,500 miles per hour. If light travels through ether, they reasoned, then as the Earth moves through the ether, the speed of light should be different going with the ether than perpendicular to it. In an attempt to show the effects of ether on the speed of light, Albert Michelson and Edward Morley conducted an experiment in 1887 at what is now Case Western Reserve University.
Compared to the speed of light, Earth is not moving that fast. So if you're going to check the difference in the speed of light, measured with the movement of the Earth compared with transverse to it, you need a level of precision that no one had before. The Michelson interferometer was just such an apparatus.
Michelson and Morley devised an apparatus that would detect minute differences in speed between two beams of light. Light from one source is split into two directions through a half-silvered mirror. These beams are bounced between other mirrors and then recombined back into a single beam. When two light beams combine, if their waves are completely synchronized, the peaks combine to make an even more intense peak. If they are one half wavelength off, their peaks combine and cancel out the intensity. Slight differences in speed between two light waves will therefore produce a pattern based on the amount of interference between the two beams. This is known as an interference pattern. Examining the interference pattern from the two light beams sent out in different directions would clearly show if the speed of each light beam were different in different directions. But Michelson and Morley never detected such a difference. Their results were inconsistent with the existence of ether.
The scientific world didn't know what to make of it. The famous scientists in Europe, all Lord Rayleigh and Lord Kelvin and Lord Thomson, were saying, hey, come on, you must have done something wrong here. There has to be an ether. And the whole thing didn't get resolved until many, many years later when Einstein came along.
Einstein's theory of special relativity proposed that the speed of light is always the same, regardless of the speed of the light source. The results of the Michelson-Morley experiment were entirely consistent with Einstein's view of the universe, and this served as the turning point in modern physics.
The Michelson-Morley experiment was an experimental advance in technology that transformed science. Not only physics, but science.
So the first question is, according to the mainstream heliocentric model, did Michelson-Morley debunk the ether?
Yes.
Yeah, of course it did. Stupid flurf. We already know that there is no such thing as the ether. Michelson-Morley debunked it. That's all it was about. The next question is all that is needed to explain Michelson-Morley from within a heliocentric framework the removal of an ether? So to put that simple as possible.
Yes.
Yeah, okay, there you go. Yeah, of course. All that it proved was our only option was that there is no ether. That explains why we didn't get the interference pattern. That's why we got 0, because there is no ether. That explains it. There's no problem. They were just trying to detect the ether. They weren't able to prove the ether because they didn't get an interference pattern, so it debunked the ether. That's all that Michelson-Morley did. It had nothing to do with the motion of the Earth. It had nothing to do with anything else. All it did was disprove the ether. Okay. Can we use an interferometer to detect the motion of an object moving in a curved path?
Yes.
Yeah, of course. That's how we detect the rotation of the Earth with ring laser gyros. It detects the object, in this case of the Earth, spinning, and that's how we know that the Earth is a rotating globe, because we use the Sadek effect, which is interferometry, to measure the motion of the rotation of the Earth, right? Which gives us an interference pattern. Okay.
We can take a trip back in time to the Michelson-Gale-Pearson experiment in 1925, which used a modified version of the Michelson-Morley interferometer to measure the Sagnac effect of Earth's rotation. The experiment confirmed the angular velocity of Earth as measured by astronomy.
Star rotation. So their prediction matched the results within 98% accuracy. What are the odds, right? The interferometer kept showing an interference pattern that basically perfectly measured this phenomena. In fact, for years we've been told that's one of the primary evidences or proofs that the Earth is rotating, is that the ring laser detects its rotation by using an interferometer and
the Sagnac effect, and is so precise. Not only do modern aircraft have 3 fiber optic gyros on board to measure yaw, pitch and roll, but it can actually measure the rotation of the Earth at Bob, how much was that again?
A 15 degree per hour drift.
Thanks, Bob, by the way.
You have a device that's designed to measure rotation. It measured rotation normally, how it's designed. You were very successful in measuring the rotation of the Earth.
So next question, can this be done without an ether? Yeah, of course, because we just covered that the ether's been disproven, and that's all Michelson-Morley was about. They think that the ether has been debunked. They don't think there is an ether, yet they are claiming that the interferometer is detecting the motion of an object in a curved path. In this scenario, the Earth that they believe is a globe that spins, right? Is the Earth moving in a curved path around the sun? In the heliocentric model, yes, the Earth is moving in a curved path, right? Because it's curving,
Okay.
it's orbiting around the sun. So if
half curve.
yeah, exactly. If an object's going around something else, it's curving. Then the next question is, can interferometry be used to detect an object moving in a curved path with or without the ether? Now that may sound redundant, because it is, and it's because you literally have to sneak it back in there to make sure we're still on the same page in real life application. Can interferometry be used to detect an object moving in a curved path with or without an ether? Yes. The answer has to be yes. If the answer is not yes to this, then the globe earther could not claim that the ring laser gyro is detecting the rotation of the Earth.
You were very successful in measuring the rotation of the Earth.
Thanks, Bob.
Did the interferometer in Michelson-Morley detect the assumed orbit of the Earth? The answer is no, from all sides. Would removing the ether alone explain the results of Michelson-Morley?
I don't think so.
Right. The answer is no. No, because we just established that it can detect the motion of an object in a curved path even without the ether. So just getting rid of the ether wouldn't explain why it didn't detect the motion of the Earth. Then, now what that brings us to is, did Michelson-Morley debunk Newtonian mechanics? The answer is yes. When Michelson-Morley didn't detect the orbit of the Earth, immediately it debunks Newtonian mechanics. Right? So if you wanted to keep the orbit, you had to get rid of Newtonian mechanics, and you have to get rid of the ether. So
Yeah, then they're gonna have to put in something else, though, right?
yes, exactly. So because there's also the removal of Newtonian mechanics and its replacement. Because obviously you need some type of dynamic claim, a mechanical claim, right? A mechanism to cause the Earth to supposedly move around the sun, right? And so since you're getting rid of Newton, you're going to have to replace him. That's where Einstein came in. That was relativity. Now, what did relativity say? What did Einstein say to fix the situation? Well, Einstein said that the Earth is actually free falling in a linear path. And because it has a linear speed, right, and on the Earth it's just going straight, it's free falling, right? Then you won't detect it with the interferometer, because there's not an actual force acting on the Earth. It's not physically pulling it around the sun from the Earth. There is no actual force pulling us in a curved path. We're actually just free falling without a force acting upon us in a straight path. Therefore, the interferometer could not detect it. Okay? The last question here, knowing that Einstein had to replace Newton for this to be explained, is if relativity was required to explain the results of Michelson-Morley by claiming that the Earth's orbit could not be detected, then would a consistent detection of motion falsify relativity?
Oh. Yeah, I guess so. Yeah, it has to be a yes. Like that, there's no ways around it.
I know, it just seems so simple to me. It's like, wow.
And it is, dude. Like, you put it to the point where a 5-year-old can understand this crap.
Yeah. Either it's going in a straight path or a curved path.
Yeah.
And
which first off, that is just silly and ridiculous. I don't know. Like, I had no idea that what I was believing in, that we're believing that we're literally free falling in a curved path. It's like that. Honest to God, if I'm going to be honest, that sounds made up. Like that's just ridiculous.
It's worse.
It's dumb. Like who? Like I never knew that was what the globe like actually believes, and that's what I believed, and I didn't even know that shit. Like I'm supposed to believe that we're free falling around the sun, and that's why we can't. That sounds just made up,
right? You tell me I believe
that's ridiculous.
Better not be me.
Yeah. But I do apparently. Like I didn't know that. I didn't even know that that's what I believed. You know.
How do you feel about that belief, though?
Well, I feel like that I'm being fucking bullshitted. Like I just don't understand. Like, where did you come up with that? Like, show me how you proved that we are free falling, curving around the sun. It sounds so ridiculous. I want to know how you know that. You know what I mean? That's where I'm at with that. It's like that's just ridiculous.
Yeah, the answer is because that has to be happening to explain the test, or the Earth is stationary. That is the only answer. So do you agree that if relativity was required to explain the results of Michelson-Morley by claiming that the Earth's orbit could not be detected, then a consistent detection of motion would falsify relativity?
Oh, well, if a claim is shown to be false, then that would falsify that claim.
There you go. And you notice how even then you couldn't just say yes? Like, why can't you just say yes, right? Like, why? Like,
it's all hypothetical because it hasn't been shown.
Oh my gosh, how is he not being bad faith at this point, right? Like,
I guess if you cover your eyes, then you can say it wasn't shown to you, I guess.
Yeah, but wait, before you even take the bait on that, it's like, it's a hypothetical preface. If relativity was required to explain Michelson-Morley by claiming the orbit of the Earth could not be detected, but there was a consistent detection of motion, would that falsify relativity? Well, it's just a hypothetical. It hasn't been done yet. I know, that's why it has a hypothetical preface. The answer is yes. It's absolutely yes. Right? Because now you have nowhere to go. Would it falsify relativity? Yes. That's actually been done. It was done at the time, and we read the quotes from Einstein saying, well, if Dayton Miller, who was replicating Michelson-Morley, hundreds of thousands, actually millions of measurements, if his measurements are correct, if his results are true, and they're not just some fundamental instrumental error that we can't figure out but must be there, then my whole theory is wrong. And if his whole theory is wrong, the heliocentric model is wrong. It's been replicated, again, over 5 million measurements, and replicated even in the 21st century. So there is a consistent detection of motion, even though relativity stepped in to try to save the heliocentric model by claiming that you can't actually detect the motion, and that it should be zero, and that when you get the friendship, it's just an error. Well, it's been consistent. You don't have instrumental error consistently caring about cardinal direction, caring about altitude, caring about solar motion, the equinoxes. That's not how that works. You know, if my watch is 1 second behind, it isn't accurate when I hold my hand to the east, but then inaccurate and 1 second behind when I hold it to the west. No, it would just be 1 second behind. It wouldn't care about direction. It wouldn't care about altitude. It wouldn't care what time of the year it is. There would be something in my instrument that's wrong that makes it 1 second off. That's what instrumental error is. So, in conclusion, heliocentrism has been falsified, and in fact, for over a century.
Not everybody can be a robot polisher.
This conversation seems to require very specific sequential binary questions to get to the bottom of it, because the propaganda and indoctrination is so strong around the subject. You should ask yourself, why? Why is some test with light beams like gotta be so lied about, right? Like, that is super weird, right? That's kind of random.